Um, hmm. Okay, how about now? I think it seems in the monitor that everything is right. So, welcome to our weekly live stream, coding a Raspberry Pi Zero emulator from scratch. This week, yeah, I can see the comment in the chat, probably history, but there was no audio, so it's good that I checked it. Yeah, building a Raspberry Pi Pico emulator from scratch. Last time we did USB. Thanks, Steve. I see the audio is working now. That's great. And we sort of got serial over USB to work, at least in one direction. And this time, I hope we'll organize the code a little bit, refactor it, and get full duplex communication over serial USB. Before we get started, let's just share my screen. So yeah, that's the getting started guide. I don't think we'll need it anymore. Anyway, before we get started, I just want to show you a new cool feature I added to the Walkway simulator last night. And it's very useful if you want to debug PIO code. So here is just, let's make the font a bit larger. So here is just a quick example of a PIO state machine that reads from a keypad. And if you run it, it's just a short Python code that tells you which keys you pressed. So I press 8, it says 8 pressed. And this new feature actually lets us look under the hood. It's where was that? Logic analyzer. So it basically lets us record the digital signals that are traveling across these virtual wires. Let's just wire it real quick so I can show off and you will see how it's working. Basically, it has 8 digital input pins. D0 to, I'm not doing the wiring very beautiful, but it will still work. D0 to D7, and we are connecting them to the keypad pins. That's exactly the number of pins. So we will be able to record, and sorry about the ugly wiring, but it will still work. Let's also do the ground thing. Yeah, so now if I play the simulation again and I press a few keys, you will see like those LEDs light up, indicating there is activity. So all those 4 lines, they always have activity as the machine, the state machine is sampling the, I think these are the rows of the keypad. And then when I click on a specific, actually it's sampling the columns, and when I click on a specific row, it doesn't matter where, you can see the corresponding bit going up in the logic analyzer. So it's getting data. And when I stop the simulation, I will get a file with all the signals, and then I can open it in this software pulse view. Change this to 1 so it loads faster, and you can see here like these are like the 4 channels scanning the columns, I think. So you can see it's setting each of those channels to high one at a time repeatedly, and then you can see whenever I press the key, then the corresponding pin went high together with the relevant row or column. I mean, this is like how it's scanning. So whenever the spot of the matrix on the matrix matched the row and the column, then this went high. So yeah, so that's I think it's I really love this feature. I played a lot of it with it today, and I would love to get your feedback about it. And I think it's also going to be useful at some point in the future when we add USB simulation, because then people will be able to actually see the protocol in front of their eyes, just like here. Anyways, hey Tomasz, good to see you here. Back to USB. And one more thing before we get started, Paul Dixon sent me this YouTube video from Ben Eater. It was released literally 3 days ago. I watched it just a few hours ago, and it does a really good job explaining all the USB enumeration and setup packets and descriptors. So basically what I was struggling with last week. Too bad we didn't have that video before. So I also posted a link to the chat if you want to check it out. It's like 30-minute-ish, and it does a good job. Like he shows stuff on the scope and then explains the data with by looking at the USB standard and pointing out all the fields of the packets. Anyways, so let's see, where were we after this short introduction. We had a simulator, and we had this hello USB program that we ran. And if we start this now, I think it will print something, because that was, yeah, it prints hello world every second, which is quite cool. That was where we got last time. And yeah, terminate this. And we also have this file with USB notes. I don't know if there is anything interesting to look at here at the moment. Let's look at the change log. I think there were a few other changes since last week. Oh, this is just me opening an issue. What is that? Never mind, I don't think we need it anymore. So yeah, let's take a quick look at the commits. So yeah, this is last week, I think. Yeah, this is last week. We can now transmit data from the device to the host. We still need to implement receiving data from the host. We'll do it, and a usage example. And then there was a failing test because we fixed the NVIC behavior. So I basically changed the test to, I also removed a bunch of magic numbers and replaced them with the constants. But yeah, I'm not even sure which test I fixed. I think this one, yeah, where I just changed the interrupts bits according to how we changed the logic in the NVIC, even though I'm still not 100%, it's like the right way to go. Anyways, and removed some uninteresting console log we mistakenly left in the PIO. Also fixed a few bugs in the PIO, like, oh, yeah, I remember this. This is actually one that the one of the students from the Pi Pico deep dive course reported. We forgot to check for interrupts when we updated the FIFO. So when we pushed or pulled things, we forgot to update the interrupt flag. So basically just checking for interrupts after every FIFO change. And then there was also this like enormous two enormous test cases that actually that checked that we actually raised the interrupts. So that was one fix from last week. And also that's really small, just reset the number of cycles whenever we restart a state machine. And there was also this one, apparently PIO also needs atomic register access. We figured it out last week for USB that it also applies to USB, so PIO is also a peripheral. I don't know why we excluded PIO and USB from atomic register access at the first place. I think because they have a different, they are connected to a different bus or something like that. But anyway, this fixes it. I just removed those ifs from read uint32 and write uint32. So all those, so all those if statements, and just added PIO to the list of the peripherals, this big list of peripherals, just like we did with USB last week. So yeah, so these are all the PIO related fixes I did since the last stream. Nothing new on the USB side because we are going to do it today, right now. And after we finish this review, let's go back to the code. And yeah, I think the first thing we want to do here, we sort of hacked together this USB, which does both USB and the serial communication. And I think it would be wise to remove all the CDC stuff and to move it into a different class. So the USB only handles like the USB low level stuff, and then all this protocol stuff, like there is this thing that sends setup packet, and all of that stuff will go into the USB higher level implementation probably. So I think we'll just open another directory for USB, and we'll have like interfaces.ts, which will include all the USB. And it's a small bit of, we are writing here a small bit of tiny USB, but it's a tiny USB. So all this stuff basically can go here, and then we can also create another file for CDC. And yeah, this all has to be exported. So export, and then yeah, I guess we can yeah, I guess setup packet is something that no, I actually want to receive the setup packet as just, you know, a buffer. So let's have I don't know, let's create another file, setup.ts, and create setup packet that will create a new setup packet, new uint8 array, and create setup packet params. What was the name of the interface? Setup packet params. Yeah. Export function, of course. All right, and then we can return this setup packet. And on the USB end of things, we will just get a setup packet, which is a uint8 array, and just use it. So it doesn't have to care about the protocol. And then, yeah, and for all of this, we can probably, yeah, we can probably create functions as well. Like function set device address packet, and there will just be nice wrappers around create setup packet, so sort of helpers. And also this, not return. I don't think it's legal to have a double return. Let's add all the missing imports, and voila. So yeah, so there is like USB peripheral now. And what else do we have here? So yeah, I think we need to sort of expose those kind of events. First of all, let's move this one into the CDC stuff. CDC class export class USB CDC, and it gets the USB instance, of course, read only USB controller. And maybe in the future it will make sense to, you know, extract this into its own library of USB.js or something like that, and make this part like agnostic of the controller type. But for now, let's just create it specifically, but at least in a separate file using a separate class, just nice separation of concerns. And then when we are sending this, for instance, we are going to send this.usb.send setup packet. No? Oh, it should be now public, not private anymore. And I guess reset should also be public now, because it's something that we want the outside world to be able to do. and let's import all of those. And yeah, I want to import all of those, and then we can have this dot initialized instead of cdc initialized, because this is only cdc, right? And we'll get to it in a moment. What else do we have here? So we have all these what is SAE status doing? So if we send up received, I think this means we are sending the ACK, I think, if I'm not mistaken. And this means we are, yeah, we are probably clearing those bits. So I'm not sure if this is actually where we are sending the ACKs for the device resets, or, I mean, this means that the device received the reset. I think protocol-wise, the device doesn't do any kind of reply to the reset. It just waits until it starts getting data from the host, but we'll probably, for now at least, fire an event to indicate that the device processed the reset. Yeah, and all of that is probably USB specific. So how do we, yeah, so I think for now we can probably, no, I want to start adding, like, sort of like we had this, first of all, this on serial data can be moved to the CDC class, because now it belongs to CDC, and we also don't need this CDC initialized. And where did we use that? Yeah, so let's see. So I think what we need to do now is basically yeah, expose this event. So there is like an event for on bus or on USB enabled, and by default it's just, you know, doing nothing. So if nobody attaches to it, we just don't send a reset and everything is fine. So this dot, no, we just want to call it. If it's defined, this is a TypeScript syntax that says call it only if it's defined. And then inside CDC, we can just attach to this event on USB enabled, then send a reset, this.usb. And, you know, other implementation can decide how to deal with that. And then this.onReset acknowledged, I don't know, or onReset received. Yeah. It's like when the device indicates that it handled a received packet. So here we can create this member, actually declare property. And yeah, it's again taking nothing, returning nothing, and optional. And then we can say here this.usb on reset received, and we want to set the device address to 1. And I guess this is private, or maybe no, we need to set a packet and then set device address packet with 1. I think that's how we call that new function. Yep. And what else do we have? So we have this device configured, set device configuration. So this is basically going again. So on packet acknowledged, I guess. And I'm not sure this is actually clearing this bit of setup rec means we are acknowledging the packet. It might be so. I think there is another way, but we'll figure it out, or maybe not. Acknowledged, and then this this is something the CDC will take care of as well. So let's create this missing property, and this.usb on div packet acknowledged, then just do this logic, and then we can take care of private device configured. And again, set a packet, set device configuration. I think we should call it set device configuration packet, just to make it consistent with the other one, with the other ones. Yeah, configuration packet. Okay, and again we have this dot initialized. If it's not initialized, then set this. And now I think we are finally ready for like the last and most important callback, where is we need to declare the type of this. So again, optional, and it gets nothing. Yeah, I knew if I missed something. Acknowledged. Yeah, now it looks correct. And yeah, we had this this part where we got data, and then we sort of need to decide what to do with it. And this is where we are going to yeah, we are going to tell the device that we are this dot on endpoint right, and we are going to use what is this buffer, I guess here. So endpoint and the buffer, right? Yeah, I'm not sure. I'm not even sure what we are doing here. We are probably telling the sort of returning control of the buffer, and then indicating to the endpoint that it's ready for it to reuse or something like that. And then yeah, and then we can, so basically we don't need this if. We are going to indicate this in any case. And let's create this declare property, and we still need to do the other side, but we can create the interface for that. This is USB on endpoint write. So whenever there is a write, endpoint number. Oh, we don't need the types. They will be in the event listener. So, and then we can for this, for writing to endpoint 2, we'll just forward it to the serial data listener. And here we had this method. We need to define the type. So endpoint and buffer uint8 array. And this returns void. Okay, and now we need to run the code again and see. First of all, there is some error here. What doesn't it like? Maybe we need to yeah, create setup packet with these parameters, and then it will be fine. Okay, and now let's change our code to use this to set up this CDC. So const CDC new USB CDC. USB CDC with mcu.usb controller, and then cdc.onSerialData. And why is this not auto importing? Did I forget to export it? No, it just didn't update the import from src USB CDC. So now it will be able to import it. And let's run the code, and if everything works well, we should see hello world again, or maybe not. Apparently we messed up something in our refactoring. How unpleasant. Okay, let's try to I guess there is like all those debug prints. There is only one debug print actually. Let's try to just print a few messages. Console.log USB enabled, and USB reset done. So we are setting the device address and sending set configuration, setting control line state, and finally let's add endpoint write and endpoint and buffer just to see what's going on here. I hope we'll get to this endpoint right. Yeah, it's endlessly setting the device configuration. So I guess we should probably have indicated somehow that the device has been configured. How did we do this before? Reset device configured false. Nobody sets device configured to true. That's interesting. Oh, that's the new one. Yeah, so this happened in set device configuration. So basically this dot device configured equals true, and we can probably remove this from USB as well. USB device configured device go away. Yeah, USB probably doesn't need to care about that. And yeah, now we got past the where we were in the last time, but we still don't get the rights to endpoint number 2. So it's set configuration, set the control line state, and now it got those acts, I guess, for the set configuration, set control line state, and yeah, maybe we should you know, just send those packets after we get the X. It feels more it makes more sense to me. So if endpoint equals 0, then, but you know what, let's first get it back to work. I don't know why it stopped working. If you have any idea, let me know in the chat. Otherwise I will have to figure it out on my own. What did we change that caused it not to work? Maybe some other flag we forgot to set. So yeah, we had this one, and CDC initialized after setting the control line state. I think we still do that, right? Yep. And then the question is why we don't get the data on endpoint 2. Let's take a look at USB endpoint. So yeah, and there might be this where I think this is, I mean, we had this, like, we changed this condition a bit. Maybe if we revert to the original condition, it will fix it. So it was, before it was like this. Let's see if this is the reason for the breakage. No, as I suspected. It doesn't make a lot of sense anyway. Yeah, I don't know. Let's see if it's still trying to read from the USB CDC. So here, console.log, read from endpoint and endpoint. No, it's not even trying to read from it. So it seems like setting the configuration or something like that didn't go so well. Yeah, we'll spend a few more minutes trying to figure out if this is one of the which one of the changes. Of course, it's one of the changes. But if we can't figure it out, then we'll resort to debugging, because we'll need to debug it soon anyway, I guess. Device configured, then so this should be taken care by on packet acknowledge, and I think that's what it does, right? In the CDC. CDC, packet acknowledged. So yeah, it probably does the same. Set device configuration 1 and sending the control state. And yeah, I don't know. This is calling the endpoint right, and we only, and what do we don't get here anyway, so it doesn't really matter. And device configured start with false. So it shouldn't really matter because we are doing the USB reset anyway, USB enabled. And then, yeah, well, I can't figure out what went wrong, why we are not getting there. So let's go debugging this. So we had this, where did you go? GDB multi-arc, yeah, we have the line ready from last time. And it's probably not going to be very useful because now we are just waiting inside main, but I think there was like this method, and here the USB nodes may come handy. Yeah, there was this method in the SDK that was something with CDC enabled. CDC something. Yeah, we have all those files open from last time. Too bad I didn't take note of all the interesting method names, but it has to be somewhere. CDC, or yeah, all these tud or tad. Echo serial port. Had CDC available sounds like where. Let's set a breakpoint there and continue, and it might break there when it gets to the next break, or maybe no. Where's the implementation of this? Yeah, I'm not sure if this was the one I was looking at last time. Don't think this is the one. Even though it looks familiar. This is inside CDC device. There is like this, whether the USB-D enabled, I think. And let's try to restart the simulation and see if we can get this breakpoint to work. That was inside emulator run, removing execute, going back to GDB, and breaking in this. Yeah, I think this is, I remember this CDC connected. So let's break here, continue, and we get here, cool. And then third ready returns. It doesn't tell us, so let's step into it and finish. So it says false, so bummer. This is in TAD mounted, and I think TAD mounted looked at this, or maybe it will return true in the future. Let's give it another try. Let's make this a bit larger so we can actually see false, and again false. So it's definitely not doing something that it should. Step, where are we? So it didn't get the CFG num, I guess. USB focus command. USBDef. Yeah, it didn't get the configuration number, even though we sent the set configuration packet. So that might be the problem, or this may be where the problem lies. Let's go back to CDC, and we are sending a setup packet with set device configuration packet. And yeah, this calls create setup packet and send. Did anything change in send setup packet, or and we changed some of it, but I think that it gets this uint8 array, which should probably be the same. Yeah. And let's see if it got the address though. There was this USB dev, and it's connected, and it's not even addressed, so it didn't get the address. So it seems like something is wrong with sending the setup packets. Let's just, print them and see if they look legit. Yeah, if only we had tests. But yeah, this time we didn't spend time creating tests. And yeah, we can see it sending an empty setup packet, which is quite interesting. So that must be a problem here. Probably in create set. Yeah, we haven't set the size of the uint array, so it got 0 size. The uint array, that was the problem. Let's now run it again and see that all is working despite not having tests. Yeah, we can see the hello world and these endpoint writes. Cool. Yeah, funny to see that it actually writes the hello world in one packet and then these in another packet, the /r/n. Anyways, yeah, we can probably remove all this fluff from the CDC driver. We don't need it anymore. It works. And let's go back to this USB, and now we can remove this whatever that was. Yeah, I wanted to remove this condition so it gets to the whoever is listening anyway. And one cool thing about it, in the future, we'll probably be able to just somehow plug a tiny USB, compile it with WebAssembly or something like that, and plug it to all these event listeners and actually have whatever kind of host implementation we want. So have the full range of, or maybe not the full, but a wide range of USB host options available. Anyways, there are a few console logs still here, like we don't want this one, and I think that was, yeah, we still want this one because we want to implement it, but we don't need this. And now we should be happily getting hello world. Yeah, only this read from endpoint and hello world. And the first thing I wanted to try to fix now is instead of using this packet acknowledged, which is not really acknowledgement, it's more like the device indicates that it processed the buffer, but instead of that we are actually going to wait for the actual acknowledgement. So let's try to see if that works. So if somebody is writing to endpoint 0 and buffer.length is 0, that's what we have seen. This is actually just an acknowledgement. And let's see if that works, if we still get hello world if we do it this way. Yep. So I think that's a more a more correct way to implement that, because obviously the hardware, the host device never knows when the so I think where the whenever the device finished processing the packet, it only reads the acknowledgement. So I mean, in a real world situation, there wouldn't even be this reset received. It would just, wait some time after the reset and just send the setup packet. But for now, I think we can live with that. But let's just remove this this fake callback. Yeah, we don't need it anymore. We can live without this. And yeah, still hello world. So nice to see. Okay, so yeah, I think we can commit this. There are a few warnings, but that's just a few unused bits. We don't have to worry about it for now. Yeah, so refactor USB, move CDC stuff to separate class, and let's also add the issue number. So that was issue 70 something, 66, 70 something. Yeah, so issue 66 to separate class, and we can push that. And now we can start focusing on the other end, like getting data from the host to the device over CDC. So I think there is like these buffers that read from endpoint that we are getting. They are, where is that read from? Yeah, they are here. Let's also print the buffer out dot length. No, that's just so there is like this buffer, which is probably where we should write the data. I'm not sure, but we can try to check if this is the case. Actually, I think slice returns a copy, but there is a way to return, I think uint array slice returns a copy, but there is a way to return like a reference to a part of it. Slice extract return a new array with new underline buffer. But how can we do a slice and get the same buffer? Or maybe we don't want to do this for, actually I pretty like the idea of copying this buffer when we are writing, because in this case we are passing this buffer to somebody else, and in that case they may modify it, so it makes sense, to make a copy. But here we probably want to I guess we can just get, so we can probably call this dot on endpoint read and uint 8, and then yeah, endpoint, and we can create, now we can create like uint 8 array view sub array. How do we do that? Sub array, return a new type on this. That sounds good. So sub array sounds like what we need on the same array buffer with the same element, exclusive. Okay, so this dot rp2040 usb dpram slide sub array buffer offset plus buffer lengths, and then we can just give the user this buffer. I'm not sure if this is the correct buffer. Let's actually modify this hello USB example to read some data. I guess scanf just reading a name or something like that. I hope I'm doing this correctly, but we can We can probably test it on the actual Pi Pico just to make sure it makes sense. So cd build, I think, and make cd hello US. I think it's inside hello world USB, and then there is this hello USB. So should we just test it on the simulator, or should we? I think it will make more sense to first upload it to the Pico. So let me just reset it. Oh, I need to reset it with the bootloader. So yeah, so now we can copy this file, copy hello USB uf2 mntc prp2040js, and then we can open this folder just to make sure our test program does what we think it does. Hello USB uf2, and paste it in this drive, and then we can open PuTTY and use serial, and I don't really remember which serial port the Pi Pico uses, but I have this. I have a few, COM16 and COM20. Interesting. Let's try this one first. This is some Python. Oh, that's my that's my smart name badge that is connected and running CircuitPython. Let's disconnect it so it won't confuse us. So new session, COM20, that's the other one, serial, COM20, not COM1. And then I can type URI and hello world, some junk. URI, hello world, more junk. So yeah, so obviously it's not working as I hoped, but at least now we know it's not. If we got the same result in the simulator, we would be baffled. Yeah, I forgot to, silly me, forgot to add the argument. So let's recompile this, make, copy it again, and reload the Pi Pico. Restart and copy uf2 and restart PuTTY, start session, and now I'm typing URI and it says hello world URI, and now I'm typing Steve and it says hello world Steve. So there is no echo, so I can't see what I type, but at least I can see the code is receiving it and it works. So now that we know we got it right, let's copy this L file and also this hex file and run this and see what happens. I mean, I don't expect anything interesting to happen because we still haven't implemented the part that reads, but let's declare this property. Endpoint number and buffer uint8 array, and it's not return anything yet. I think we should somehow indicate how many bytes we read. I remember we had this, like, I mean, there must be a way to tell the USB controller, the USB device, how many bytes we read. Why isn't it happy yet? Yeah, optionally call this. Let's just start it, and it will probably not do anything interesting because now it's reading a lot of data from an undefined memory address, which is strange, and writing to an undefined memory address. That's strange. We didn't have that before. Yeah, and we can see it's reading from endpoint 2, and I don't know, strange thing. Which address is that? Is that like, no idea. Yeah, 2042. Let's 242. Let's search for that in the datasheet. SRAM end. It's past the SRAM end, and I think there is nothing there, so we are probably we probably have some invalid data that causes the program to read from those addresses. But let's add and write to them. Let's add the PC here. Read from the console.log this.pc.string16, so we'll be able to place a breakpoint there and then see who is writing there. Yeah, this. Okay, let's restart, connect with GDB, break here, break, start this address, continue. It's in scanf, is it? All right, interesting. Impure data. Okay. So scanf is reading from an invalid memory address. How comes? Name is just all zeros. I think that should work. How did it get to read from an invalid memory address? Yeah, I don't know. Maybe we should try something simpler then. There is like, I don't remember, there is like a C API that reads a string without all C read string, without all this scanf stuff, gets, puts, gets. Yeah, fgets stdio. So I don't know if there is like a bug in, probably we don't have getLine in, do we, in this SDK? Think not. Oh, that's not the SDK, that's the examples. We do have getLine, but I'm not sure. Yeah, this is part of the PIOASM. I mean, we can try that, but I don't think that's a standard thing. GetLine, len std in. Let's see if it even too bad we can't use scanf. I mean, I think it's, I'm not sure. I don't want to spend time debugging this right now, but I think this might be a problem and somewhere else in the simulation that causes. I don't think we ever used scanf before, so it might be some problem in this enormous function, some issue that it uncovers. Yeah, I think what we're going to do now is just we can probably use getC or getchar and just, you know, build the name character by character for now, just so we can see it works. Oh, we said it's nobody, even though I don't think this kind of initialization worked for us because the name was nulls. Anyway, getC. There is getchar and getC, I think. Get a character from std in. It's equivalent. Okay, so it just returns. While get car isn't new line, then name index, then name at name index plus plus equals, or maybe we can do this ch, then in ch, or it could be just a car ch. Or actually, what does it return? I think it returns, it's probably blocking, I guess. not sure. Anyway, we can just make our life simpler and just get one card at a time and print it. Not as fancy, but it will do the print the hexa value of it. It will do it will do the trick for our purpose. Not as fancy, but still does the trick. Let's just make this and test it on the Raspberry Pi Pico first. And let's see, we had here, oh, we need to copy this first, Uf2, and then this goes here, and Paddy, com20, serial, doesn't like it. Let's try that again. Device manager, Paddy. There is com20, so I don't know why I didn't like that. Maybe we tried too soon. Yeah, now I hit A and I can see the uppercase A and a space bar and a new line, and it prints the hexadecimal code, or sorry, the decimal code. So yeah, so this works. And without scanf, let's copy the hex file and the elf file and run it now. And let's see if we got more lucky. Maybe it wasn't a bug in scanf after all. I mean, not a bug in scanf, a bug in the simulation. Yeah, now it's getting zeros, which is interesting because we aren't putting anything in that buffer, but we also don't indicate. I mean, somehow we indicate to the device that there is like the valid data. Otherwise, we wouldn't get zeros. Let's try to diagnose it by, in this endpoint read, just filling the buffer with f's to see if it's endpoint read, endpoint and buffer, and just let's buffer.fill with f5 or maybe 42 because it's printing the decimal value. And if we are lucky, we'll get 42s. Yeah, so we are writing to the correct place because we see that the code is reading from there, which is great. But it shouldn't, I guess. I mean, there should be a way for us to tell the code that we don't have data yet. So let's take a look at this Dpram documentation. USB, and there was like this programmer module, initialization, and receiving a packet. Okay, and then there must be something that talks about the Dpram, maybe not, architecture. All right. Data buffers. Okay, so then I remember there was like this, yeah, all those endpoint controls that included information, and maybe this is where we should write the amount of data that we have. Okay, no endpoint, interrupt enable, single buffer, double buffered, enable interrupt, double buffered, interrupt. Okay, so this is the configuration. And here we have the buffer control register. Available transfer links. hello world. Yeah, we should have done that. Yeah, so it could be that we need to write back to the lengths the number of bytes that we actually have. Let's try that. So just where is that length? That's the control rate value, I guess, or where do we get the rollback. That's the buffer offset. We get the length from this value, which is in buffer control or out buffer control. So it's basically it is offset. So I guess we should just and the length is like the lowest 10 bits. So we can probably do something like const updated value, and then we need to return then we need to return remove those bits, and let's for now just set it to 0. So let's write it this dot who calls Dpram updated anyway. I think it's called from the RP2040 after setting the value, so we can easily update it. This dot RP2040 dot USB Dpram view dot set uint32 offset and updated value. So if I got it right, now we shouldn't get any hello world statements, because we are just saying, yeah, this looks good. We are just saying, you know, the endpoint is empty, there is nothing here. Let's just try to see what happens. So let's do this const new length equals to this, and then we can do new length, just update the length as indicated by this function. Let's say it returns number now, like how many bytes we should receive. And if we didn't get anything, or this function is undefined, then we return 0. That's the, you can actually use this syntax. So now it should still, oh, it failed. Why did it fail? Yeah, because this function doesn't return anything in the CDC, and we said it should. So let's now return 1, and each time also return a new number in the buffer, like next, let next equals 0 and next plus plus. And if all works well, we should see now 0, 1, 2, 3, and that will be a good indication that we are actually, no, it didn't work. We are not getting anything. Yeah, let's try to see, to print the console.log new length. It should be 1, but maybe it's not. Yeah. So yeah, I guess, what if we returned yeah, this clears the bits, and this should set the bits with a new length, and the length is always the lowest 10 bits. So maybe this is not how this is done. Let's try to look at a code that reads this and see what it expects. So I wish I remembered where this code lies, but we can probably try to look at it's probably not inside a CDC device, but inside the RP2040 USB. Yeah, this looks like a good endpoint transfer. But where is the place where we are reading from the endpoints? Start next buffer, control update. There is like total length and transfer size. What is this EP HW endpoint? Where is that defined? HW endpoint configured RX. So there is endpoint control and buffer control, and these are like internal registers of the code. They are not part of the hardware. And then buffer update, start next buffer. So following next. Yeah, let's take a look where we are taking, where it's reading from the, there was this buffer control. Where are we reading from the buffer control? This is like updating the buffer control, but there is probably something that is reading. Set value. It's reading the value here, and what does it do with it? Rx. Oh, that's interesting. Transferred byte. So where is transferred byte come from? Yeah, transferred byte is coming from buff control, USB buff control, lenmax. So I think this is exactly, what we were writing to. Let's put a breakpoint here and see what happens. Why we're not getting the data as we hope. Interestingly, there is also one read and then things just sort of stall. I think at this point we are past this read. Yeah, I already killed it. Let's run it with... Yeah, I think it's stuck somewhere because we can see it's somewhere in the CDC device. Yeah, let's run it for once and see where it gets stuck. Maybe it will give us some information, and if not, we'll set a breakpoint. Where? Yeah, some assertion. Buff control and buff control full. Oh yeah. We already yeah, I think we had this bug last time where we updated it and then updated it again, overriding our changes. So that's why it doesn't work now. We should just, update the value in place, because we are also updating it here, marking buff control full, setting this bit to let the receiver know that we have data for it. Okay, so maybe now it will work. Let's see. Thanks GDB for helping us finding the issue. And yeah, reading from endpoint 2, so it does read a lot, but it doesn't print anything. So I think it thinks there is like no data. Yeah, even though we are returning 1 here, which means there is 1 byte. So let's try to just see with GDB what's happening. It's looking at some FIFO. Okay. Oh, it actually worked, but after reading a lot of data from the endpoint, very slowly. But we can see now it prints 0, 1, so it does get the data. I don't know why it does so many reads at the beginning, just to get 1 byte at a time until it's happily starting to send data. But at least we can see now that we can send data bidirectionally, byte by byte, and it sort of works. Yeah, I think the next logical thing would just be to connect it with the console. So let's keep this one for now, this read from endpoint, and let's add a new method to the CDC, calling it write data, and you can give it a uint array. Maybe write transmit data, like tx. Transmit data, because this is on serial data, so maybe send serial data. And then we can say this dot, just add the data to some kind of internal buffer. So transmit buffer, just an array of uint8, and then we can also, or maybe we can just use a FIFO for that. Transmit. We have a FIFO implementation already. TX FIFO, new FIFO. And let's say it's a very large one with 512 items. And then tx FIFO dot push const item of data. Now it's not the best implementation in terms of efficiency, because we are going to we could have just copied a whole portion of the array, but we are not worried about efficiency right now. We will probably at some point in the future, but for now that should be good enough. Let's also set it const tx FIFO size. And then when somebody is asking for serial data, we can do something like that. When they are reading from this, we can for let I0 I less than buffer dot length I plus plus. So if this dot tx FIFO dot empty, if it's empty, then just return I, the number of bytes we read. Otherwise, endpoint or buffer at I equals to this dot tx FIFO dot pool. Cool. So it should probably, and eventually we just return this dot buffer dot length if we got here, then not this, just, and all of that only if endpoint equals to, and instead of using this magic number, otherwise we just return 0 if we don't recognize this endpoint, we have no data. And let's use also this cdc endpoint equals to, which we can use here instead of this magic number 2. All right, and I think that's it more or less. We also need a way to to connect this send serial data with our emulator run. And we also have already have like, I think, a piece of code, or we don't have, I think we have it in the MicroPython. Yeah, that reads the data. So let's just copy this into the emulator run for now. And I think once we get it to work, which is, I hope in a moment, MicroPython is next. So we'll get to that in a moment. So set row mode on data. Instead of this, we are just doing cdc dot send serial data, and yeah, we can probably just make the interface simple send serial byte, and whoever wants to, or yeah, whoever wants to send more than a byte can just call this multiple times for now. All right, and let's npm start, and now it should just take my keystroke. So it's reading, and then I press something, HELLO, and yeah, I think that the data is coming but for some reason it's still maybe new line. No, so yeah, the data is coming, because if I type a lot of stuff now, I think we'll start seeing, or maybe not. I mean, it worked before after a lot of reads. Let's connect with GDB and see what's going on. So yeah, the interesting thing is whenever I connect with GDB, it continues running, even though it's in a breakpoint. Yeah, but we can probably set a breakpoint here and see in this function and see what's going on. Yeah, it got here, and then transferred bytes 0. yeah, transferred bytes. Maybe there is a problem with the FIFO then, because I think one other thing we probably want to do is maybe yeah, maybe we shouldn't always return from endpoint read immediately, because we are always telling it, hey, there is data, there is zero data, but there is still data. So I'm not sure this is the correct thing to do. I mean, if we debug, this is the actual hardware. Let's see if it gets into that function that often. So this time we want to, we also have a breakpoint from last time. So connecting to the Raspberry Pi, which is connected to the physical device. And then let's break here. And yeah, you can see like it's not breaking until I actually send some data. So I think there is like transferred bytes will probably be 1 if I knew how to spell it. Yeah. So yeah, so and then interesting, I got, oh yeah, I should be there again, probably because I just send data. So that's the ACK. So yeah. So anyways, yeah, I think it doesn't make sense. I still don't know why. Let's actually console.log endpoint read, and we return hi here, and return buffer.length, and here we just return 0, just to see if we should return 0 most of the time, I guess, because we have no data. But then when I press on some key, we should return another number, and I think I could spot yeah, a few ones here. So we did return a bunch of data, but I think those empty buffers that we send all the time are confusing. So instead of doing that, then we can probably do something else. Instead of having this method return synchronously, we can let the user know that somebody has read from the endpoint, and then just omit the buffer and have another function that the user can call. Or yeah, we should, don't know if it's a good idea to, yeah, for now let's give the user control of the buffer, even though I don't really like this that the user, you know what, no, let's just give him the length of the data, byte offset, so buffer length. So this is how much we want to read, count number, byte count, and then we'll expose another method that lets the user sort of indicate that there is data. There is let's call it endpoint read done. So just below here, endpoint read done, and then the user can give us a buffer, and it should have enough data to or less data than whatever the user the code requested. And then whenever we go here, we can probably do this, and we'll need to store some of this data internally. Or maybe the user can say endpoint, just tell us the number. We'll trust the user not to mess up with this too much. So yeah, and then we can say we need the that's always an in or out buffer. I think it's out because it's going out from the device to the host, or no, it's in, it's going in from the device to the host. It's always, as Graham said last time, it's always from the host perspective. So there is like this buff control, which is endpoint, which is in buffer control plus Oh, it's actually out. Yeah, because this is in if buffer out. So yeah, so out buffer control plus endpoint, I think times 8. Yeah, that's the difference between those. EP. Yeah, I think that was, let's just verify with the datasheet, but I think they were spaced by, so in buffer control out, yeah, by 8. So out buffer control. Yeah. And here we just want to do it for every endpoint. No, so basically we can just, you know, change this whole structure to just if and else. And we have this buffer here. We don't need it anymore, but we'll need it in a moment here. So let's move this code here. And we now have this buffer control register at offset, and we can control reg and let buff control value this.rp2040 USB Dpram read uint get uint 32. We want to get the buff control reg, and there's a little Indian, and then we want to indicate that it's full, call indicate endpoint ready, and yeah, basically do all of this stuff. Move it here to the callback. So buff control value, and then new length is actually the received buffer.length. Yeah, we can probably as a safeguard const new length is just the minimum between the buffer lengths and the yeah, and the requested lengths. That's the current value of the buff control. How did they call it in the SDK? I will probably just copy the name of this mask, USB buff control len mask, instead of repeating it. Yeah, buffer control const 3ff, and then we can let go of this magic number everywhere. And there was one here as well, and one here and here as well. Okay, and this is taking the new lengths, so it's the minimum between the buffer lengths and the supplied the requested buffer lengths. And why do we have another buffer here? Yeah, we can just call set it and give it buffer.slice or subarray, so we don't copy it from 0 to the end is the new length. At the offset, we should get the buffer offset from the control reg value, which is, yeah, it's probably worth creating a method to read this these registers, otherwise it gets kind of messy. Read endpoint control, endpoint number output boolean, and then this returns. Do we use this offset here? No, just here. So move these two lines here, control reg, and then we have endpoint and out, and we return this. And here we can just call this dot read with the endpoint and buffer out. And we can also do this. We use this reg value anywhere else? Not really. So maybe we can create another method, read get endpoint buffer offset, which will also do this. Return this.read endpoint with endpoint out, and the buffer offset is depending on the endpoint number. So if endpoint is 0, then we just return this like magic value. Otherwise, we return this these bits from the control register value. And then we can replace this with just endpoint and buffer out. And this, then we can reuse the same logic here to get the buffer offset. And we don't need this. And this is always out in, right? In. Okay, this seems better. And yeah, we don't want to assign this to buffer. I think we should, let's just remove the word value from here. So we get a buff control register value, request the length. Then we update the lengths with the new lengths, indicate that it's also indicate that the buffer is full, update, and we need the buffer control reg offset with the value, with the new value, update the buffer in the Dpram and indicate that it's ready for consumption. Yeah, I think we have done with this small but challenging refactoring. And then inside the CDC we can say private waiting for data, and whenever somebody is reading here, if we have data, then we can probably, if this dot txFIFO, if it's not empty, we can call this dot, we can set this dot waiting for data true, and if it's not empty, so we can send data to device, and we can move this whole piece of code to the new private send data to device. And yeah, maybe have another private buffer size equals 0, and then when we get new data, it's giving us the size, this dot buffer size true. It's actually out buffer size. And then no, that equals size. We can const buffer new uint8 array with this dot out buffer size, or no, we want the buffer to be. Do we have like a way to know how many items are in the FIFO? I think there is like size. So we want the minimum between this.tr out buffer size and this.txfifo.size. Actually, item count, not size. Size is the total size. And now we just want to fill the buffer with items and call this.usb. We call it read endpoint. No, those should probably be private as well as this one. Endpoint read done. And that was cdc endpoint, and give it a buffer. And also whenever there is like, oh, and also here we can say, yeah, we don't need to return anything. And here we can only do this if this not waiting for data. If the device is not waiting for data, then don't do anything. And finally, after we send it, this not waiting for data equals false. Maybe we should call it device waiting for data, for, not from data. And then after pushing anything new, we can just send the data for to the device if it's waiting to. Let's make this also, it could be protected if somebody wants to extend this class in the future. All right, let's try to see if this works. We wrote a lot of code and it doesn't. Yeah. Yeah, Dpram updated. We should probably haven't. It's RAM updated. It shouldn't be private because it's called by the RB2040. Okay, reading from endpoint 2. Now I'm going to hit H and we can see it works. Whenever I type something, it's echoed. Who can tell me in the chat? I mean, yeah, that would be simple. I typed low, but let's try something more challenging. Let me type some secret word and see who gets the meaning of those ASCII codes as fast as possible in the chat. Yeah, I'm monitoring the chat to see who is the first who knows what I typed here. Anyway, this is pretty exciting. We now got bidirectional communication, and it's sort of abstracted out in this CDC class. So it's totally optional for applications to use this, or to just use this USB class directly and implement their own protocols. There was like this video I showed before from Ben Eater, who showed how to implement a keyboard using HAD, or how the HAD protocol works. So if you want to do that, good luck with that. Yeah, any console logs here? Nope, not really. Okay, so let's commit that and fit USB CDC in CDC input or CDC serial implementation, and that was issue 66. Let's remove this Uf2 so it doesn't confuse us. Yeah, and I think before we commit, let's just quickly review the changes. So yeah, we don't want that, for example, so that was a good idea to review this change. So yeah, that makes more sense. Nothing changed here. Here we just added a few registers and a mask, added this new on endpoint read, endpoint control register. Yeah, all this refactoring we did in the last few minutes. Endpoint done. yeah, nothing too much. And then in CDC we added this TX-FIFO and, you know, all this logic to support USB on endpoint read. I don't know. So plus USB callback, also implement CDC serial input. Yeah, I think that was the big change, like implementing bidirectional communication over USB, and now the adding CDC support like was a secondary thing. Yeah, so that was just double checking. 66, right? Yep. USB endpoint read, or maybe better message. Let's undo that. Yeah. Implement endpoint reading. There was writing, now we have reading. And also CDC on top of that. Yeah, more happy with this description. Let's push it. And now on to the next challenge. So we got CDC working bidirectionally. Let's see if it works with MicroPython. Right now we have MicroPython, but it works over, like, it's a custom build that works over where was that? Emulator run. No, that was MicroPython run. So we have this MicroPython run, and it works over UART using a custom build. I think, yeah, I changed this enable UART REPL to 1, useful if there is no USB. So it was useful, but now it's no longer because we have USB. If we start it, you know, or npm run start MicroPython, I think, then we get the MicroPython REPL, or we should get it eventually. Might take a few moments. Yeah, print hello world. That's for you, Steve, and it slowly prints it. But that's like over UART. Now I'm going to be a bit ambitious, and, you know, just download the latest MicroPython Pi Pico release, and see if that works out of the box. So that's what I would love to have. Where is the MicroPython though? Yeah, downloadable Uf2 that lets you install. That's like from literally, no, that's from last month. Let's paste it into the folder and see. Oh, that's a Uf2 file. Yeah, is there any hex file? Just we have let's see, Raspberry Pi Pico. Yeah, it's a Uf2, so, but it's the latest version. So yeah, I think let's be a bit less ambitious and just build our own hex for starters, and then we can try with the, you know, official download with the Uf2. But let's first just disable this, disable the enable UART REPL, make this board again, and see that we don't get a UART REPL, but hopefully we get REPL over USB. You can see it's rebuilding everything now that we have disabled the UART REPL. Yeah, Steve says it was a bird, right? I typed bird. Good job, Steve. Cool. So where did we go? Yeah, it's much easier with hex, I guess, but you don't always get hex. Okay, copy build pico firmware.elf mntcp rp24djs MicroPython USB only.elf, and same goes for hex. Let's try this MicroPython USB only. That's here, and we are going to load MicroPython USB only. So now when we run it, I expect to get no REPL because it's USB only. We'll wait a few moments, and yeah, we can see there is no REPL. And now let's just copy the code that attaches to this CDC. So instead of this UART, let's implement this CDC. Yeah, that's very similar. Apparently you don't have to wrap that, I guess, or maybe here, yeah, it's already uint array. And the same goes for the other direction. Yeah, I think that's it. All we need to know to do now to upgrade this code to USB, and let's start it and see if we get a REPL. And we are waiting, patiently waiting. And still waiting, but we are not getting any REPL, bummer. So luckily we haven't relied on the downloadable version, so we have the L file, and we can also try to debug it and see where it gets stuck. So MicroPython, no USB, right? And we get stuck in nowhere. Interesting. Maybe I had a USB only. It's only USB. It's not no USB. USB only. Where did we get stuck? Network. Oh yeah, I want to go. I wonder what happened to the network, but we don't need the Raspberry Pi Pico. Yeah, interesting. It dies somewhere, inside an assertion in an unrelated place. Bummer. The good thing, or maybe not so good, it seems like we got into the friendly REPL, but that makes me wonder, why didn't we see any output if we got into the friendly REPL? Let's just add some debug prints to the USB to see if anything is going here. So let's actually, we can do it in the CDC if it's even getting to reset the CDC, the USB. USB enabled, and let's also do CDC initialized, just to see, to get, oh, that's funny. I typed Control-C and now I got into the REPL of MicroPython. That's interesting. I don't know. Let's continue. Don't know how this happened, but yeah, it works. That's MicroPython REPL over USB, and I almost Control-D to kill it. I almost didn't get it because for some reason when you start it you don't get anything, but if you type Control-C then USB is suddenly enabled, and USB is now enabled, and yeah, after initializing the CDC, for some reason it waits for a Control-C to start showing stuff. Interesting. So yeah, it's a bit slow, but it's still useful. So false alarm. It takes a few moments until we get into USB enabled and CDC initialized, but only if we send something. Let's see what. Yeah, it's sort of, it just sort of in the REPL at some random point. So I guess it's sort of like it takes some time to initialize USB, I guess, or something like that. So we don't get the output from the very beginning, unlike with the serial, which is available from the very beginning. So we don't get the beginning of the output, and I guess that's why. But we can still print a bird, though. Yeah, it's so slow, though. So cool, we have MicroPython working with the USB REPL. That's pretty cool. So I think the next step, the next logical step would be to Steve is 5 minutes behind the live. Had to take a phone call, so thanks for coming back. Anyway, so that's cool. We have USB working on MicroPython. We can use now USB instead of serial, and let's try to use the out-of-the-box build of MicroPython. So I just downloaded this Uf2, and let's see if we can get it to run. Oh, we already have this bit. This is like the build, the official build from MicroPython. Let's see if we can get it to run without any changes. So the first thing we need to do is to install this Uf2 library. It's a JavaScript library I wrote a few months ago. I was pretty optimistic. That was like January 31. So I think it was like a week or so after we started the live streams. And I was pretty optimistic that we'll get to the point where we can run off-the-shelf MicroPython and CircuitPython. So I said we would probably need a Uf2 loader to load these files. As you can see, it took almost half a year until we got to the point, but it's good being optimistic. It's not a very complicated module, just 169 lines of code that implement this Uf2 format. It's pretty simple. If you want, you can read about it later, but for now, we are just going to copy this usage example to load this Uf2 file into our MicroPython run. So, yeah, we already have FS, and you can import those two from the Uf2 library. Yeah, and then we can open this file, not Blink, but RP2 Pico 2021-618 v116 Uf2. And we can initialize a buffer, and then we have like this code that loads it block by block, and we need to do something with the payload. And what we'll do is just let's call it function load uf2 file name string, and rp2040 takes rp2040, and then we can just say rp2040 dot set. How do we do it in the hex loader? Load it into the flash, and yeah, so dot flash dot set hex flash address minus probably this offset, and then just the payload. And why isn't it happy about this? Yeah, that's the other way around. You copy the payload at this address. Let's have this, yeah, let's include a file name here. fs.opensync. It doesn't like it. File name. Oh, we need the flex. fs.openMode. Number or string. Okay, so read, I guess, RB maybe. And now we can just call here, instead of loading hex, load uf2 and give it a file name and the rp2040. We called it MCU here. Yeah, and let's see if this works. Out of the box MicroPython loaded. Yeah, it didn't. It doesn't like RB, so it's not like Python. It just wants probably R without a B, which stands for binary in Python. Okay, so we can see like it loaded all those blocks. The family seems correct, so the family comes from the Uf2. It's one of the ways Uf2 allows us to ensure that the file is compatible with the board. And I'm going to type something and see if we get it to the REPL. So yes, print. It's even faster. I am production grade MicroPython running in the simulator. So yeah, I think this is the, oh, it takes a lot of time to print that. it's still a bit tired, and we'll have to work on optimizing the speed probably in one of the next live streams. But this is the first time you can just, you know, download MicroPython as is and run it in the emulator without any changes. I think this is pretty awesome that we got here. Let's move this code into load uf2 and it's pretty cool that this uf2 code worked just, you know, out of the box. Let's move it here. And from now on, our MicroPython run is going to run the release version of MicroPython. You don't need to build your own version. And then there is OpenSync and ReadSync, which we can just import from FS. And yeah, I will make a note to myself to fix the use example here. I can actually do it right now, I guess. Just add here this missing R flag that was inside OpenSync. So yeah. So doesn't show me the diff. Okay. But I know what I changed. Docs add missing flag. It's called flag or flags? Flags. Or fix usage example. Add missing parameter flag parameter to that was in OpenSync. Commit directly. Yeah, that sounds good. And that's a small change. Let's see. Yeah, just fixing that usage example. So yeah, it took us 5 months to go from the, or almost 6 months to go from the first commit to this small documentation fix. Small but important. Okay, so let's export this and export function, and then we can remove these prints, and once we remove them we can also get rid of all of this code that was only used to make this print prettier, so it's short and sweet. Here we can just use load uf2, and let's start this again just to see that it still works. Yeah. So I'm thinking to make this a bit more user-friendly, maybe we should also add another callback on device connected, and then we can automatically send a new line when the device is connected. So so as soon as we are setting the control line state, I think we can say this dot on device connected, and in the MicroPython example we can say cdc dot on device connected. Then we want to send cdc send serial byte, just, you know, /n string of char code at 0, that would return the ASCII code of /n. Let's try that. So now I expect it to automatically get into the REPL without me having to type, to accidentally type something just to drop into the REPL. And yeah, doesn't seem to work. Yeah, if I type something I can see it, but for some reason it didn't, or maybe it did. Let's console.log device connected, and let's see what happens now. Yeah. Funny. Yeah, we don't get, oh, we did get into that device connected eventually. We just had to wait a bit. Why is it running so slow? maybe we should. Yeah, I can see why. We are executing 1000 instructions at a time. Let's bump this number up. So every time it executes 100 instructions, 1000 instructions, and gets back to the event loop, and that's making it run slowly. Now let's see a fast MicroPython running. So yeah, you can see it's connected much faster, but for some reason sending /n is probably not enough. Let's try sending R and then N. Maybe we need both of them. Doesn't make sense to me though. Yeah, it did the trick though. We get into the REPL. So interestingly, it waits for both /R and /N until it shows us something. So we don't need this, and we can slice it into 2 commits. What did we change here? Oh, the number of iterations. Fit USB, add on device connected callback to CDC. And then for the demo project, we can say something fit demo load or run. Let's first review the changes. So we added the Uf2 library as a development dependency, so we can use it in the demo project, and this obviously changed our package lock JSON. Let's also add this Uf2 files to gitignore, since don't want to accidentally commit them, and then here we don't want to change anything for now. Maybe in the future we'll have another demo for the USB, even though I think MicroPython does this pretty well. Yeah, so fit demo, run release version of MicroPython, use the Uf2 loader, or load the firmware from a Uf2 file instead of hex, and also initialize the USB REPL. And here I'm going to say something like, to explain this, we send a new line to see the MicroPython prompt. Now I'm actually curious to see if we get the same behavior on the physical Pi. I guess we will, but let's just test it. So I'm going to set up MicroPython here, and yeah, just copy it here. This Uf2 just, flashing is so convenient. Let's restart the session. It can't find COM20. Maybe the out-of-the-box release doesn't work so well on the actual hardware. Interesting. Let's try to reset it. Maybe it uses a different COM port? Yes, it does. COM14 for some reason. Okay. Yeah, and you can see I open the terminal, but I get no output until I press a new line. So that's it's pretty weird behavior. I understand why it's like that, but I think in terms of user experience, it would be nicer if I had seen some prompt. When I tried it on the simulator for the first time, I didn't even realize it was working because I didn't see any output. Send a new line, so the user gets the MicroPython prompt. Okay, cool. Or user sees the MicroPython prompt. Cool. Fit demo, run release version of MicroPython, load firmware from Uf2 file instead of hex, and also initialize the USB REPL. Cool. So now we have MicroPython that runs the out-of-the-box, the release version in the emulator. And let's also fix API 2040, run more instructions per execute, or maybe it's not fixed, it's performance. Speed up execute run instructions at a time instead of just. So now it's no longer I mean, for the low UART 1000 at a time, or yeah, 1000 at a time was more than enough, but for something as big as MicroPython we need more speed. So this is an easy way to squeeze more speed to reduce the idle time of the code. And now we are done with MicroPython. Let's be super optimistic and try to just, you know, download CircuitPython and see if that works out of the box. That would be amazing if everything just works. CircuitPython Raspberry Pi 0 download, 0 Pico download. And there is CircuitPython 630. Let's try that. Actually, interesting. I wonder why they did this gray. It looks like it's disabled, but when you move the mouse over it, it shines. Strange. Anyways, so let's copy this and let's see if we are super lucky and it just works out of the box and we like MicroPython. And I'm not very optimistic because with MicroPython we have done a lot of debugging in the past. So I mean, we knew that it works other than the USB, and with CircuitPython we never tried it. And CircuitPython has like more USB stuff in it, like USB mass storage and that stuff. So let's try. I don't know. Let's see if we get anything. It's running. GDB is listening. And it seems like there is no REPL. Let's see if this is even connected. CDC connected. I mean, one thing that could be is that we need to select a different device configuration for the USB, because maybe the CDC uses different device configuration. But at this point, I think it didn't work out of the box. I would have been surprised if it worked out of the box. Let's give it a few more moments. But at this point, I think it will make sense, you know, just to build it. I think I have it here on my, yeah, I have some version of it on my PC, so I can try to build it for the Pi Pico and see, yeah, let's just git pull to get the latest and greatest. I don't know if we need it. And let's also, yeah, let's just get the most recent version. And where are we? We have some changes here. Git submodule update. I always forget what I should do, but yeah, it seems like it is happy. And let's move to this RP port. Raspberry Pi, and then I think we also need to run, yeah, it makes sense to read README when trying to compile something. Build. Oh, building sounds good. Setup. So yeah, let's just run these two to make sure we are synchronized, and run this. And finally, we should go into the port. So we are in the port. If you have a fast computer with many cores, I think I have 16, so I will add -J something. I don't know how they got 17 from 6 cores 12. Just added these numbers and subtracted 1. I don't know, but let's try that. But let's see. Oh, I already done a build of it a few a few days ago, I guess. But let's just, you know, make clean board equals Raspberry Pi Pico, but now I know the board name, and let's make it. And I'm not sure if I'm going to get debugging symbols. Is there anything? Oh, debugging, yeah. So does it say anything about building with debugging symbols? Debugging, J-Link, not interesting. Yeah, I guess we should just debug to 1. Let's make clean debug 1 and J. I'll try 33. Let's hope it's not gonna kill the the stream or something like that, taking over the CPU. So now it should be compiling this big. Yeah, that was pretty quick. So now we have a Uf2, and we should also have a hex file. Uf2, but we don't need the hex file. Let's copy this. It's pretty large. RP2040 P, RP2040 JS, firmware or CircuitPython.uf2, and same goes for the elf. And let's start debugging like we always do. So now we can load CircuitPython Uf2 that we have just compiled, run this thing again. We still call it MicroPython, even though it's running CircuitPython now. And let's connect with GDB. So that would be CircuitPython.elf. Where are we? We are stuck here, I think, in this RTC disable alarm. It seems like it's reading this it's in a sort of a while loop stuck here in this RTC disable alarm. What is that? So we didn't even get to USB. That wasn't the problem, probably. RTC disable alarm. Yeah, it waits for this. What is RTCHW? Yeah, GDB just. Do we have an RTC? We do have an RTC peripheral, and we are just returning like, it's probably something, some kind of mock just to make this kind of functions happy. What is this IRQ setup 0? It's reading from this, and it wants this to become low. So I guess if we just return 0 here, it will be happy. IRQ setup 0 registers. Yeah, so let's try to just return 0 here. That was 10 hexa, right? IRQ 10 hexa. Yeah, one day we'll also implement the RTC, but for now, let's just return 0 and see if that makes CircuitPython any happier. Starting this, and I'm not very optimistic, but let's see with GDB. Oh my God! It actually worked. Whoa, that was easy. Hello, CircuitPython. This is how I like things. Like everything works this time. I think that's the best session we had in a while, where things just work. Let's also try the previous version that didn't work. Yeah, just a small fix, and my CircuitPython also runs. I thought that would be much more complex to get it to work, but apparently we did a pretty good work. I'm still not sure why scanf wasn't working. That's worth investigating. But let's see. Oh, I think we were pretty lucky with the new version, but for some reason the old version this 630 still doesn't work, which is interesting. Let's try to download the latest version and see if that works. That was here, this alpha 7. Maybe it's maybe it has to do with the debugging symbols, but I'm very excited that we even got it to work, like we got a REPL and everything. That's so cool. Yeah, let's see how it goes with the release version of this 7.0.0 alpha. Yeah, this works. It even says code done running. So in this case, we are even getting to the REPL before we, I think that was also, no, yeah, that was sort of the case with the version that we built, but here we actually get the REPL with the version number, and that's super cool. So yeah, we have CircuitPython, and for some reason it's only version 7 that is working. So let's try to figure out what's wrong with version 6. Why doesn't it work as well? I hope it will be as super simple to fix as it was with version 7, but for now, fix RDC, change register to make CircuitPython happy, or just make CircuitPython happy, implement IRQ setup 0 register, which is used during CircuitPython's initialization. Okay, make CircuitPython. You are happy now. And yeah, and now where were we? Where were we? We wanted to compile CircuitPython, but 63x branch. So let's make clean here. Oh yeah, we must provide a board parameter, of course. Make clean, and let's also run this PyPros and this submodule update thing. Maybe we should first run the submodule thing. Let's just see what we should do here. That was inside building. Yeah. All right, making this MPyCross, and then we can make create a debug build that was make with this debug equals 1 minus J33. And yeah, it compiled MPyCross. Now it should be compiling CircuitPython 6.3 something, and we can see if we can reproduce the issue and then maybe fix it. So copy this to CircuitPython 6.3x, and same goes with the Uf2. And I'm so happy the Uf2 is also working just, you know, flawlessly. I haven't tested it too much, but I think it's, no, you see, it's working. So CircuitPython 6.3x, and let's try that. And we expect to get no REPL, but now we can debug this with GDB. So CircuitPython 6.3x. Where are we? Who? Yeah, HW line state in USB device enumeration. So yeah, probably something that have changed in between SDK version, but we are reading HW line state. What is HW line state? Where are we anyway? Yeah, DCDIRQ, HW line state, fix busy wait, fix wait. Let's try to see if there is any documentation for that. But at least now we know we are in the USB land, which is what we are working on right now. Yeah, this is where we are. We are waiting for this to be different from SE0. And I don't know when you need this. Yeah, after coming out of reset, the hardware expect time before it will move. However, I have the broadcast packets for over the devices. Okay, so this seems like some kind of edge case, and we want we are reading this SAE status line state bits. So let's take a look at this SAE status register. That was here, USB, SAE status, and there is this line state. So what's up with line state? No information. USB bus line state. Okay. Maybe just looking for line state. I think this is like PAO. This is not USB. A specific initial line state, SE0, etc. So there are like a few line states that bus reset, connected, suspend, resume, data 1, data 0 that need to be detected. Okay, so what is this SE0? And how is this line state encoding this? It's 2 bits, so there aren't too many options. Yeah, so let's take a look at the constants. So it's looking at the bits, and there is SE0, which is 0, J, K, and SE1. So I'm not sure which of those we should. Is anybody looking at those? Yeah, there is like a place where I don't know if anyone calls this. This function. It's called. Yeah, there is some strange stage machine here that forces those lines and checks for them. So yeah, let's try to Google that and see if I can get any information about those line stated SE0, SE1, J, and K. SE0, SE1. Okay. So SE0 indicates reset, disconnect, or end of packet. SE0. J and K states. Okay. So SE1 should never occur, and SE0 is just when both D plus and D minus are driven low. So I guess we should just maybe work around this issue just by indicating this. I mean, there is SE1 should never occur. Nobody is checking for this value. Yeah, let's just set it to LSK for now, because nobody. What is the LSJ go doing though? Is it waiting for it to be equal to LSJ, or? Yeah, it wants it to be equal to LSJ. Yeah, let's just set it to LSJ and see what happens. So I would do this right after reset, I guess. USB TS, and there is like when we even I guess we can do it when the USB is enabled. Status, or yeah, maybe after bus reset received console.log. Let's just check if it gets here. Bus reset received. Let's see if we actually get to this point with CircuitPython, and if this is the case, then yeah, bus reset received, yeah. And then at this point, let's just set this bit to this dot SAE status. So we can probably call SAE updated here. And then we should remove those bits. Line state. Is there like any constant for this? Line state. So actually, let's change it to line state shift. It's 2, and const SAE line state mask, which is 3 for 2 bits, right? It starts at bit number 2. Then we can say something like we are just setting those bits to 0, and also setting it to let's copy those constant. Yeah, SAE line states, or enum SAE line state. That would be more readable, I think, than using constants. Equals, and that should be it. So here we can just say SAE line state dot j shifted by SAE line state shift. All right, let's see if this did the trick for CircuitPython 630. Apparently we get a bus reset, but we are still not happy. Why aren't we happy? Oh yeah, I know. I can see the bug right in front of my eyes. Yeah, so we should mask these bits first, and then this.SAE status or equals, and there might be another way to do it, but this should do the trick, I guess. Now let's try that again, and yeah, we should get a bus reset, and shortly after no REPL. Why is that? GDB, help us please. Where are we stuck now? Yeah, now it's looking at SAE status connected bits while it's not connected. So we passed this check, but there is another check that we need to pass. USB device enumeration. That's line, but in the Pico SDK, I want the one in the MicroPython. CircuitPython, sorry, enumeration. That was line 133. Enumeration fix finish. So it's waiting for the SAE status connected bits to be 1. So let's try to set it to 1 and see if that works. Or SAE status connected. No. Status connected bits. That's bit number 16. SAE connected. Okay. Let's try that and see if this did the trick. Trial and error oriented programming. Bus reset received, but we are still not there. Ooh, yeah, we are in this IRQ, so we got further. And there seems, no, there is a new line because of the GDB. We seem to get into the IRQ, but for some reason, we never get out of the IRQ. Yeah, I wonder if any of those changes caused it to be confused. Maybe we fixed one thing but destroyed another thing. So let's try for a moment run this MicroPython again and see if it still works. No, not the GDB. Yeah, this still works, so we haven't destroyed anything, which is good news, but there is still something. It's probably an older version of the SDK here, which for some reason still doesn't work with our implementation. And we should run it again probably. But we did get it a bit more working. I don't know why it's like stuck in the IRQ. Let's see what happens. Probably some, yeah, oh yeah, I think it's trying to clear this, and then we are always setting it again. So maybe let's just give it another try. If the SAE bus reset is cleared, then we are setting this SAE connected. Yeah, but it only happens once because we otherwise would have seen bus reset received, but for some reason maybe we can just, you know, does this clear the SAE connected? Yeah. What if we let it clear the SAE connected? Maybe that's the problem. Not sure. I'm just blindly guessing here, but you know, just trying to get it to work before the end of the stream, maybe. And it worked amazingly. Wow, that was a wild guess. Cool. Yeah, I'm not sure if I did the right thing here, but it works, which is what matters. Let's just try the release version once more. So this is the release version. Let's see if this works. Running, yeah, even the release version works. Print, I am so happy to work for you. It's so happy to work for me. Cool. And yeah, that's amazing. So we got 2 versions of CircuitPython, which is apparently a thing to work here. And I think we also added some debug print here that we should remove. But other than that, I think we are ready to commit this last minute fix. I hope I won't be sorry for committing this without understanding what exactly I did, but fix USB, make CircuitPython happy. That's part of issue 66. I think actually for now we can close issue 66. We have USB pretty much the way we wanted it to be. I think for the next few sessions we can focus on other things. If you have some ideas, let me know. Write to me here or in the Discord channel what we should work on next. Otherwise I will probably come up with something next week. But for now, yes, we can use the MicroPython, and that's cool. So we did it. All right, so to wrap this stream, I'm going to do this commit, some work around some USB workarounds in the what was the name of that file? Yeah, in the Pico SDK USB device animation.c. All right, this allows us to run circuit Python 6.3x in the emulator. Cool, so two variants of Python in one session. I really like that. All right, so committing that, and yeah, and I think we can stash this, yeah, just we don't need this anymore. I think we could have just removed them as well, but yeah, just before we sign off, I want to, oh, we did check MicroPython, I think. Now that we stashed them, we can check if MicroPython still works after all of those changes. Yes, it does. Cool. And yeah, let's release a new minor version with those changes. And while I'm releasing, wow, 0.9 already. Yep. Yeah, and I will take this opportunity while it's releasing to thank you for joining me this session this week for the session. I really enjoyed this one. I think we had a few breakthroughs, one after the other. We still have to check out this scanf thing. I'm a bit concerned about it, but I don't know, maybe we'll do it in an offline session or maybe in the next session. It sounds like some kind of edge case, I don't know. We'll see about it, or if any of you want to take a look, then you are more than welcome to take a look at why it misbehaves with scanf. Anyway, I hope that you have a great rest of the week, and see you again next week working on, I don't know what, we'll figure it out by the time next week comes. So until then, have a great rest of the week, and bye bye.